All right, so our discussion now is if a molecule is polar or nonpolar. How did we determine before if a bond between any two atoms is polar or nonpolar? Just a bond between any two atoms. Bailey? Difference electronegativity. Yes. So I can pick any two atoms off the periodic table and decide, is it polar, is that bond polar, or is it nonpolar, based on a difference in electronegativity. And that's the first step we're going to take here. Actually, the second step, sorry. First of all, we're going to determine the shape of the molecule. And if you didn't notice, when we talked about how do you figure out the shape, the first step was draw the Lewis structure. Now that we have the shape, it's the first thing we need to figure out polar or nonpolar. You need to know the shape to decide if a molecule is polar or nonpolar. The Lewis structure doesn't totally tell you the story. It doesn't put it three-dimensional. The shape, once you understand the shape, that making it three-dimensional is what is going to help us determine if it's polar or nonpolar molecule. The next thing is we're going to draw dipoles. We brought up the idea of dipoles with the polar bear and penguin worksheet. And it defined it as a few different things. It defined it as a polar bond, and it also defined it as a whole molecule being polar, or just a molecule itself called a dipole. We're going to call a polar bond, and we're going to draw a dipole if there's a polar bond. If the whole molecule is polar, it's said to have a dipole moment. And we'll talk about the difference between a polar bond and a polar molecule again. We're going to draw dipoles. The arrow is going to point to the most electronegative atom. Bless you. And we're only going to draw the arrows if the difference is more than 0.3. Because if the difference is less than 0.3, the bond's nonpolar. And if the bonds are nonpolar, the molecule is going to be nonpolar, no matter what. So let's just do an example of water, which you already have on your sheet, but let's just do this example now. I'm just putting it up here because it's a good space and to follow my things here. Arrow points to the most electronegative atom. So you have your periodic table. You look on the back of your periodic table, and you find hydrogen and you find oxygen. Hydrogen has electronegativity. Again, we're looking at the top right number on the back of your periodic table. Hydrogen's 2.20, carbon's 2.50. Is the difference greater than 0.3? Sorry, I looked at the wrong thing, right? Hydrogen's 2.20, oxygen's 3.44. Is the difference greater than 0.3? Yes. Since the difference is greater than 0.3, this is a polar bond. Which one has the highest electronegativity, the oxygen or the hydrogen? Oxygen. So the arrow points to the most electronegative atom. So each bond gets a dipole. That's this oxygen-hydrogen bond, and this is for this oxygen-hydrogen bond. Every bond gets a dipole as long as they're greater than 0.3. All we're going to do to start with is draw dipoles, then use that information to move on to the next step. I want to do the first one with you. Please take out your Lewis structure sheet. You should have something like this as your Lewis structure for PI3. You look to your periodic table and look to see if the difference between P and I is greater than 0.3. Is it? Matt Warzala says it is. Which one is more electronegative, Matt?
The I.
The iodine. So I have 3 bonds here. One here, point out to the I. One here, point this dipole out. One here, point this dipole out. 3 dipoles because there's 3 polar bonds. Why is this important? And how do we determine if the molecule is polar or not? We're going to come right to that in a tiny bit. What I'd like you to do right now is look at all of them on that sheet. Look at the difference in electronegativity, like for the next one, I and Cl. Look at the difference, and then for any bonds, draw on a dipole. So take a little time and put dipoles on any of the bonds. What if it looks like this? I know this isn't on your sheet. What if it looks like that? What's the difference in electronegativity between 2 H's? 0. So there's no dipole. So a bond has to have a difference of more than 0.3 for there to be a dipole. So go ahead and draw little arrows on every bond on that sheet real quick. And then we'll come back to how we determine if it's polar or nonpolar.